Hello. In this lecture I will try to answer the question, is the universe infinite? The universe is all of space and time and their content, including planets, stars, galaxies, and all of other forms of matter and energy. The Big Bang theory is the prevailing cosmological description of the development of the universe. The Big Bang event is a physical theory that describes how the universe expanded from an initial state of high density and temperature. According to this theory, space and time emerged together 13.8 billion years ago, and the universe has been expanding ever since the Big Bang. While the spatial size of the entire universe is unknown, it is possible to measure the size of the observable universe, which is approximately 19.3 billion light years in diameter at the present day. It is impossible to know for sure if the universe is truly infinite. The observable universe is definitely finite. It is that part of the universe which is within 13.8 billion light years of us. The number 13.8 is because it has been 13.8 billion years since the Big Bang. So any part of the universe that is more than 13.8 billion light years away from us will not be visible or observable, since the light from those areas cannot have reached us by now. Cosmologists assume that there is a significant part of the universe that is outside of our observable portion of the universe, but it is impossible to say for sure it is infinite. The standard cosmological assumption is that the universe is homogeneous and isotropic. That is to say, it has no privilege or unique point. These assumptions seem to be correct and is confirmed in our observable universe. The universe looks the same in all directions, and on a large enough scale the universe seems to be homogeneous. If the portion of the universe that is not observable is also isotropic and homogeneous, then it could be that the universe is truly infinite. One piece of information that is needed to determine if the universe is infinite or not is to know the curvature of the universe. There are three different regimes of curvature. It could have a positive curvature, which is like two-dimensional curvature of the surface of a sphere, like in the above, like it. If the universe is with a positive curvature, it It is like a sphere. That is to say, the universe closes inwards, and it is finite. Okay? And the second possibility is that the universe has zero curvature, which is like a flat plane. Yes, like a flat plane. Then the universe is not closed but infinite. Yes. Or the third possibility is that the universe has the negative curvature, like this, which is like the curvature of the surface of a saddle. Yes? Then the universe is not closed at all. Yes? In this picture, the universe is not closed at all, and it is infinite. If the universe is isotropic and homogeneous, and the curvature of the universe has a constant positive value, then the universe will be finite. Just as a sphere, just as a sphere is finite. On the other hand, if the curvature of the universe is a constant of 0, then it will be like the flat plane. Actually, when it has 0 curvature, it will be like a flat plane, and it is infinite. Or if the universe is with a constant negative curvature, like this, that is to say, the universe opens outwards and never closes, like the saddle. Okay, and then the universe would be truly infinite. So, if the universe has a positive curvature, it is closes inwards, and it is like a sphere. Then the universe is finite. And if the universe is like a saddle, it has negative curvature, or it has 0 curvature, like a flat plane, then the universe, in those two options, the universe is infinite. So, do we have any measurements of the amount of curvature that the universe has? Yes, there is. The standard model of cosmology, which successfully fits all well measured cosmological information, has a parameter total omega, which is related to the curvature. Okay? If total omega greater than 1, like this, then the universe is positively curved. Yes, when total omega is greater than 1, then the universe is like a sphere, and it is closed. If total omega equals to exactly 1, then the universe is flat. Okay, if omega equals to 1, then the universe is a flat plane and it is closed. And if the value of total omega is less than 1, like and the universe is like a saddle, then the universe is negatively curved. The universe, when omega is less than 1, then the universe is negatively curved, and it is like a saddle, and the universe is infinite. The best measured value of total omega equals to 1 plus minus 0.12. Okay, total omega equals to 1 plus minus 0.12. So if total omega equals to 1 plus 0.12, that is 1.12, that is to say that total omega is greater than 1, then the curvature of the universe is positive. Yes, if total omega is greater than 1, then the universe has positive curvature, and the universe is in a shape of a sphere, and the universe is closed. Yes. If total omega equals to 1 minus 0.12, that is equals to 0.88, that is to say that omega is less than 1. When omega is less than 1, then the curvature of the universe is negative, like the saddle. The curvature of the universe is negative, then the universe is in a shape of saddle, and the universe is infinite. Okay? Which obviously could encompass everything from positive to 0 to negative curvature. So the universe could be infinite, or it could be finite. It depends to the value of the curvature. Okay, when omega is greater than 1, the universe is positively curved and it is closed, and when omega is equals to 1 or greater, when omega is equals to 1 or less than 1, then the universe is infinite. So there is no definitive answer at this point, but the universe is consistent with having 0 curvature, because total omega is close to 1, because it is 1 plus minus 0.12, so it is very close to 1. So we really don't know if the universe is infinite at this point, but since the value is so close to flat, even if the universe is positively curved and finite, it would definitely be much bigger than the observable universe. So we can summarize that the size of the universe beyond the observable universe is unknown, since it cannot be observed. at the moment we don't even know if it is finite or infinite. But there are speculative estimates by theoretical physicists who say that the size of the universe beyond the observable universe should be at least 250 times larger than the observable universe. Other estimates speak of a universe whose size is even inconceivably larger, even if still finite. Okay, thank you very much.